Let us try to learn Rust from the point of view of a C or C++ the developer. Let us begin with scenario 1. Let's look at the Tut03 function and a call site main. We call Tut03. We pass the address of x, but in the inside the function we modify the p to a different address. So variable x here is basically untouched. In C++, passing asterisk s to int means p receives a copy of the memory address of x. It is passed by value when line p equals asterisk ampersand x executes inside Tut03. It only changes where the local pointer p is pointing. It now points to the static x inside the function, leaving the original x in main completely untouched. So let's go to the Rust equivalent. Notice the placement of the mute keyword here. So that is the equivalent in Rust. We change where p is pointing to. So Rust behaves identically here. P is an immutable reference, and because we declared it as mute p in the parameters, the reference itself can be reassigned to point somewhere else. Now let's go to scenario 2. In scenario 2, the const is now here. So let's go back above. The const is here. So the const is to the left of the asterisk. And in the scenario 2, the const is to the right of the asterisk. The mnemonic here is to read it from backward to left. So let's go back here. Let's read this backward to left. P is a pointer to an int constant. So what's being pointed to is constant, but p itself as a pointer is not. It can be redirected to another address. In the scenario 2, let's read it backward. P is a constant pointer to an integer. So p cannot be redirected. It is a constant pointer, but the value it's pointing to is writable. So we rewrite the value here. So as a result of this, the function here in C++ will now print 69. And let's go to the Rust equivalent to observe the placement of the mute keyword here. And just like in C++, we also alter the value it's pointing to. One thing to note here is in the call site. Explanation. In Rust, to modify a data to a reference, you must explicitly use a mutable reference. Like in C++, you use the reference operator to modify the direct. Notice that at the call site, Rust forces you to explicitly write future for this one instead of just this one. Okay, you might wonder if x is already declared as mutable. Okay, why do we need mute again when calling the function? That is a sensible question. Here's why. 1. Let mute x equals 42 declares that variable as binding x itself is mutable. This gives you permission to change its value directly or to create mutable references to it. 2 asterisk x creates an immutable reference to x. Okay. Even though x is mutable as a variable, ampersand x is an immutable reference to x. This is where Rust differs, because everything in Rust defaults to being immutable. Even though x is declared as mutable, if you pass asterisk s to a function, you are guaranteeing that the function cannot modify x. So by doing it like this, ampersand mute x creates a mutable reference to x. Because Tut04 has this signature, explicitly demands a mutable reference, passing x would result in a compile error. Type mismatch. This design is about explicitness at the call site. So in C++, if you pass a variable by reference, you have to look at the definition of func to know whether x might be modified. Okay. So at the call site, it is not obvious whether something is going to change of the past variable. You have to take a look at the declaration implementation of the function. But in Rust, when you read, okay, you read in main, you know immediately. Let's highlight this. And without looking at Tut04's definition that this function has the ability to mutate x, this makes reasoning about side effects much easier and prevents accidental mutation. This is a very nice reasoning about side effects. Okay, replacement of mute in Rust. So first, mute is here, and in what, meaning that the value being pointed to is read only, but the pointer address can be changed. Second, the pointer address is fixed, but the value being pointed to is writable. And third, you can put the mute in both places, meaning that p is a mutable variable that holds a mutable reference. So again, to summarize, the mnemonic tip for C++ const placement, the absolute best trick to remember the difference between const, int, asterisk, and int. This one is the read it backwards or right to left rule. Start at P and read left. P is a pointer to an int that is const. Okay, so the shortcut here is that const is relative to the asterisk. If const is before the asterisk, the data is const, and const is after the asterisk, the pointer is const. Oh, let me read it again. If const is before the asterisk, the data is const. Yes, true. But const is after the asterisk. P is a constant pointer. The pointer is const. Correct. Okay. So the mnemonic, guys, of reading backward really helps in deciphering the meaning of this in C++. So there we have it. Granular dissertation of Rust, handling of memory pointers from the point of view of a C++ developer.